This is video or lecture 2 on the production possibilities model. Before we actually look at a production possibility curve or a production possibility frontier, let's talk about the 4 assumptions that would be present if we are actually operating what's called on the curve. So if we're achieving maximum economic output, we are achieving at first what's called full employment and productive efficiency. Full employment, again, an idea we referred to earlier in the lecture, using or putting to use all of your available resources, and productive efficiency, producing in the most cost-effective method. So if we're operating at our curve, if we're maximizing our efficiency, if we're producing at society's potential economic output, we're achieving full employment and full employment and productive efficiency. The second assumption of all production possibility frontiers is that for the time being we have fixed resources. Fixed resources both in quantity and in quality. Of course, in the future we'll find more natural gas or we'll improve solar energy or something like that, but for now we have fixed resources. The third assumption of our production possibilities model, we also have fixed technology. So we have one best method of producing goods and services, one best system of making cars, or one best software available to track packages. We know in the future, of course, that technology will progress, but a production possibility frontier examines a society's ability to produce for a specific period of time. So for right now, we have fixed technology. On any production possibility frontier, you will have a y-axis and an x-axis, so a vertical axis and a horizontal axis. The last assumption, therefore, is that we are producing two products. Now, these two products can be broadly defined, which we will see, especially when we look at the McConnell example of pizzas and robots, the one from the McConnell textbook. All right, but for now, we'll just talk about two products. Let's start off with a very simple production possibility frontier, and this would be more of a microeconomic example. Here we have the example of the Sarah study world. So Sarah is a student at any college. We'll say XYZ college, so we're not putting any college in a bad position here. So Sarah studies at XYZ college, and Sarah is taking two courses this semester. She's taking accounting and economics. Now Sarah has not been the best of students. Matter of fact, Sarah has not studied at all for either one of these classes, and her final exam, which is 100% of both of her grades, is tomorrow. It's 12 midnight, and the exams start at 10 in the morning. She doesn't have time to study in between exams, so she has exactly 10 hours of studying time left. Let's see how she can do. Well, on the vertical axis, we have her expected grade in accounting. And then on the horizontal axis, we have her expected grade in economics. Well, let's say she dedicated all 10 hours towards studying accounting. Well, that would be great for her accounting grade. Her accounting grade would be an A, as seen on the graph there. But the trade-off, the cost, because remember, when we talked about the model, we talked about limitations and we talked about choices and cost. Her obvious limitation here is that she doesn't have more than 10 hours to study, and her choices and cost. She makes a choice. She chooses to spend all of her time studying accounting and none of her time studying economics. The cost of that A in accounting is that unfortunately she gets an F in economics. Well, maybe that's not such a wise idea. Maybe she should dedicate some time towards studying econ. Well, she'll shift some of her 10 hours away from studying accounting and into studying economics. So with 2.5 hours dedicated to economics and only 7.5 hours to accounting, the choice means that she will gain something. She'll get a higher grade in economics. Her econ grade will improve from F to D. But remember, she can't have something for nothing. That's the heart of economics here. There's always a cost to her choice. There's always a trade-off. And the opportunity cost of the higher grade in econ, the improvement from F to D, is that her accounting grade falls from A to B. Now we could play this game and so on and so on and so on, but I'm just going to bring up all the possible points here and then show you her production possibility frontier. Obviously, Sarah could choose any one of these combinations. In other words, she could get an A in accounting by studying all accounting. She could get an A in economics by studying all 10 hours in economics. All right, but here's a key point. Every time she wants a higher grade in economics, she has to give up exactly one grade in econ. I'm sorry, in accounting. Every time she wants a higher grade in accounting, she has to give up 1 grade in economics. Sarah's production possibility frontier graphs as a linear curve or as a straight line. Whenever you see or whenever you experience a production possibilities model or production possibility curve that is linear, that graphs as a straight line, it tells you that there's constant cost along the curve. In other words, every choice means that there's the exact same trade-off, the exact same cost for this particular person, right? And here's the reason. Sarah is one person, this is a microeconomic example, performing two highly similar tasks, right? In other words, if she studied exactly 5 hours for economics and then stopped studying economics and started studying accounting, it might take her all of 5 seconds to put down the econ book and start studying the accounting. All right, she's performing two highly similar tasks. All right, so this is a microeconomic example. Without any other further information, what point on this curve would be allocatively efficient? So anywhere along the curve is a possibility of outcomes. But which point would be the proper mix? Well, without knowing her major, or maybe if one of these classes was an elective, or she's already set to graduate and she's going to be an accountant, so maybe she was studying for her CPA. Without any of that information, there's only one point on here that looks allocatively efficient, and that would be 5 hours of each, because she would pass both classes. She wouldn't have to hear any flack from her parents per se. Right? She wouldn't have to worry about a D or looking bad on her resume. So that would be her allocatively efficient point.